Okay, when I say volcano, what's the first thing that pops into your head? Probably a huge mountain, fire, ash, total destruction, right? And yeah, you wouldn't be wrong. But that's just a tiny piece of a way bigger, much weirder, and honestly, more creative story. So let's kick things off with a sound that literally shook the entire world. 3,000 miles. Just let that sink in. That is how far the sound of a single volcanic eruption traveled back in 1883. It was so unbelievably loud that it ruptured the eardrums of people 40 miles away. And the sound wave itself, it circled the entire planet 4 times. This was the raw, untamed power of Krakatau. So let's start our journey right there, with that sheer, world-altering force of the volcanoes we're all familiar with, the ones right here on land. And this timeline, wow, it shows this insane chain reaction of devastation. See, the eruption wasn't just one big bang. No, it triggered these colossal tsunamis, plunged a massive area, we're talking the size of Scandinavia, into total darkness for days. And then, it actually changed the entire planet's climate for the next 5 years. Just incredible. And this was the human cost. And get this, while the eruption itself was obviously deadly, the vast, vast majority of those deaths, over 34,000 of them, weren't from the volcano directly. They were from the tsunamis that came right after. It's just a stark reminder, a volcano's impact goes way, way beyond its ash cloud. But here's the thing, as powerful as Krakatoa was, it's really just the tip of the iceberg. Seriously, to see the true scale of Earth's volcanic engine, we've got to go where most of the action is. And that's somewhere we can't see it. We're going under the ocean. You see these long seams crisscrossing the ocean floor? Those are called mid-ocean ridges. They're basically these enormous underwater mountain ranges made almost entirely of volcanoes. It means the eruptions we see on land, they're just a tiny little theatrical preview for the real main event that's happening constantly miles below the surface. And this is where it gets really wild. This shot just perfectly captures the paradox of these deep-sea vents. On one hand, you've got this violent eruption of superheated, mineral-rich water shooting out. But on the other hand, look at that. You have entire ecosystems, like these shrimp here, that are not just surviving in this what should be toxic environment, they are absolutely thriving. So how is that even possible? Well, the answer is this incredible process called chemosynthesis. See, way down here, there's zero sunlight, so photosynthesis is a no-go. Instead, these amazing bacteria harness chemical energy directly from the stuff spewing out of the vents, like hydrogen sulfide. And just like that, they become the foundation of a food chain that is completely independent of the sun. This discovery, it totally rewrote the rules on where we thought life could even exist. And life down here doesn't just adapt to the volcano, it actually uses it. Take a look at this guy, the scaly foot snail. It literally builds itself a suit of armor out of iron sulfide, using the minerals that are coming directly from the volcanic vent it lives on. It is a living fortress, forged by volcanic chemistry. How cool is that? Okay, so from the creative forces of the deep, let's head back up to the surface. Because it turns out Earth still has some incredibly weird volcanic tricks up its sleeve. Okay, how about this? What if a volcano erupted mud? Sounds pretty bizarre, right? Well, it's a real phenomenon. From Romania all the way to Indonesia, these mud volcanoes are formed when geologically expelled liquids and gases just push their way to the surface. They end up creating these totally otherworldly, bubbling landscapes. All right. Or how about this one? What if a volcano burned with an electric blue flame? Well, in Indonesia, the Kawah Ijen volcano does just that. But here's the secret. The lava itself isn't blue. What you're actually seeing is the combustion of massive amounts of sulfuric gases. They're escaping at super high pressure and temperature, and when they hit the open air, they ignite and burn with this eerie, ghostly blue light. It's a surreal spectacle, especially at night. But as strange as mud volcanoes and blue fire are, the weirdest of all might just be a volcano at the bottom of the world, down in Antarctica. $6,000. That's the estimated value of the precious metal that this one single volcano sprays into the Antarctic air every single day. Everybody meet Mount Erebus. It's Earth's southernmost active volcano. And get this, its gas vents are constantly spewing out about 80 grams of crystallized gold every day. Now, the particles are microscopic, smaller than a human hair, and they get scattered for up to 621 miles. But just think about that for a second. It's a volcano that literally makes it rain gold on one of the most desolate landscapes on the planet. Just mind-boggling. But here's where we zoom out, because volcanism isn't just an Earth story. Oh no. It is a fundamental force that has shaped worlds all across our solar system. And the variety out there is just incredible. I mean, on Mars, you've got Olympus Mons. It's a shield volcano so enormous it would cover the entire state of Arizona. Then you jump over to Jupiter's moon Io. It's the most volcanically active body in the whole solar system, constantly repaving itself with lava from over 400 active volcanoes. And then, way out in the cold, dark outer solar system, you find cryovolcanoes, ice volcanoes on places like Ceres and Pluto that don't erupt molten rock, but things like ice, ammonia, and methane. Wild. So from the icy volcanoes of Pluto to the absolute giants on Mars, we've seen how this incredible force shapes other worlds. But that brings up a question. How do we keep an eye on the ones right here at home, especially the ones in the most remote corners of our planet? Well, the answer is surprisingly simple. We listen. You see, massive eruptions, think back to Krakatau, they produce these incredibly powerful low-frequency sound waves. It's called infrasound. Now, the frequency is way too low for human ears to hear, but these sound waves can travel for thousands and thousands of miles right through the atmosphere, and they carry the unique acoustic signature of the eruption with them. So how do we actually hear a volcano? Well, it's a pretty cool four-step process. First, there's a global network of super sensitive microphones that are just constantly listening for these infrasound signals. Second, when a signal pops up, scientists model the source, analyzing its unique acoustic fingerprint to make sure, yep, that's a volcano. Third, they run these complex models that account for wind, temperature, everything, to predict the sound's exact path. And finally, by combining all that data, they can trace it all the way back and pinpoint the eruption's location and scale, even if it's completely covered by clouds. And this amazing technology is actually the backbone of something called the International Monitoring System, or IMS. Fun fact, it was originally designed to detect nuclear explosions, but now this network gives us a permanent global listening system. It's become absolutely invaluable for tracking volcanic activity, especially in those remote places where satellite views might be totally blocked by clouds. And all of this brings us to a final big picture thought. We started this whole journey talking about destruction, right? But along the way, we've seen how volcanoes also create. They forge new seafloor, they nurture bizarre life in total darkness, they paint landscapes with blue fire, and they even help build worlds way beyond our own. They're this fundamental force of both endings and beginnings. So maybe the real question isn't just about what volcanoes destroy, but what are they going to create next?